All right. Let me get Mr. Lance in. Hey, hello everyone. Can you hear me? Hello.
How are you?
I'm good. How are you?
Good, doing well.
You got what? Oktoberfest
Oh
shirt?
yeah, here you the one from 2020.
Yeah, that's nice. Cool.
I'm uh, I'm waiting for the new one to come.
Great. So, how was your day?
It was great. I was working from home, so I got times to work, on things without anyone interacting with me. So
Cool.
I got
Yeah.
time to focus on my stuff. So that was great. What about you?
Yeah, I always work from home, so I always get a lot of time to focus, but less interactions, which is kind of a pain as well. At times, you want people to speak to you.
Yeah,
Yeah,
yeah. It
cool.
depends. There's people who work all the time from home, so it's kind of boring for them at one point, and for the others going to the job every day, sometimes it's great to work from home.
Yeah, true. Ideally, I think the balance can be you can work from the office like 3 days a week, and then maybe have like rest of the days at home.
Yeah.
Cool. We have some people. Hello, Calvin. Hello, Marcus, and hello, Stavo. Hello.
Hello, everyone.
Can you see the chat, Roman?
Yeah,
Or no?
I
Oh,
do.
cool.
I have it
Oh,
opened on one of my screen.
okay,
Going
cool.
to retweet. See, here we go. Cool. Let's wait for some people to join. That's
Yeah.
nice.
All right. I retweeted it. Cool. Now, can you like hear me loud? I don't want
Yeah,
to like
perfect
start
for me.
the same way I did last time.
Let me hear the feedback. Yeah, it's perfect.
Cool. All right.
Cool.
So let's do it. Let me share my screen.
Yeah,
I hope you can see it.
I do.
And let's talk about the beast, the container. So let me like start with why do you like even need something like an IoC container to start with. I questioned this myself a lot of times, like do we even need an IoC container? Do we want to like introduce something that a lot of people within the JavaScript ecosystem are not much aware of with? And the answer has been yes, we do need a container because it makes certain things really easy. But I also realized that we don't have to like go overboard with the concept of container and make everything work with dependency injection, because then like everything feels really verbose and you have to like stick to one architecture that's like you have to use dependency injection everywhere. There is no other way to build your apps. So that is something I never wanted to do, and that's the reason you don't see IOC container being mentioned a lot within the documentation. I know like we don't even have any documentation on it, but even once we are going to have documentation, it won't be like everything has to be resolved via container, because it's great, but it's not as powerful as the container that you have in other languages like PHP or Java. They like the language itself has APIs, or I would say, like tools that makes building a powerful container easy, whereas JavaScript, on the other hand, is very bare bones, and it's really hard to build some like a very powerful container out of it. TypeScript makes it a bit easier, but still, like even with TypeScript, you cannot do type hinting on the basis of interfaces and make the container work. So
because it's removed at the compilation.
Yeah. So like if the language is not that powerful, it doesn't make much sense to like find different ways to build something and force that on people to use it. But beyond all that, the container is still helpful if you are using dependency injection, and sometimes using DI can actually help you build better loosely coupled systems. So that is what I thought. Like we can actually go through how the IoC container works in AdonisJS, and I have like few examples that I can show in which the container can be helpful for you. So maybe we can start with the real basics, like where do you need the IoC container? And you need it when you're using dependency injection. So and dependency injection basically means you have a class that rely on other classes, but it's not creating an instance of them explicitly. It accepts those dependencies via constructor or via method. So that's like basically dependency injection is in nutshell.
Yep.
So let me go to basic example and look at it. It's a very simple example, and it's like not functional. It's really simple so that we can focus on the main thing without digging too deep into the implementation details. So out here, I have 3 classes. First one is local drive, which is basically the concept that I picked from the AdonisJS drive, which allows you to like basically write files to disk or S3. So the local drive says, in order for this class to work, it needs an instance of router. So I'm like accepting that router as a constructor dependency over here. Then over here, I'm using it to make a signed URL. Now, if you go to the router class basically needs encryption so that it can create signed URLs. And signed URLs are basically URLs which are like encrypted or signed in a way that no one can tamper them. So like URL itself maintains its integrity. And finally, the encryption class is really simple. It does not have any dependency. So it has a method sign, another method boot. We can ignore this method for now. And this sign method takes a value and it returns the encrypted form of that value back. So these are like basically 3 classes. Now you can think of them like classes which are shipped by different packages, or even if you think of them within your application. For example, in case of AdonisJS, we actually have these 3 classes. They are not like these, like this simple, but we do have, and they are all shipped by different packages. So there is one package that has a router class, then there's drive package, which has local drive class, and then there is encryption package, which has encryption class. So these are like 3 different packages shipping 3 different classes. And that's the reason you cannot like have these top level imports. You need to accept the dependencies. Does that make sense so far?
Yeah, all good for me.
Cool. Now, in order to use these classes now, I'm going to like create an instance of all of these classes. So first I create the instance of encryption. It doesn't have any dependencies. Then I create an instance of router. And finally, I create an instance of drive. And I'm like passing the dependencies manually over here. And finally, I call this method on drive. So if I run this code, TS ESM, this is the output that I get out of it. So essentially what we are doing is, in order to use this class, which is local drive, we have to like build the entire tree ourselves. And this is like a very simple example. But if you take a very huge application, which has a lot of things like ORM, authentication, authorization, router, server, like a lot of things, then a bunch of code within your application is just going to create and like instantiate these classes and pass them around. Now, what a container does, it makes it really simple to build these trees. And for that, you have to give container, like some hints. Now, let's say if I comment all this out, and here I will import, let's say, container. And this container basically comes from this file. So here I'm like requiring the AdonisJS fold package, which is the implementation of IoC container. I'm creating a new instance of it and exporting it from here. And what I can do is I can call this method await container.make and give it the class that I want to make. And now we can actually get rid of these imports. And here we can say constant drive. And if we talk about TypeScript, like TypeScript will have the correct type as well. So if I hover over it, you can see it has a type of local drive. So you're not like losing any type safety here. So when I call this method, it's going to create an instance of this class. Plus, it's going to inject all the dependencies that this class relies on. And then also all the dependencies that, like basically like all the sub dependencies, it will like create the entire tree for you. So if I run this code, it will fail right now. So it says cannot read properties of undefined, reading make signed URL, and which is in this, which is like basically this line. And the reason behind that is JavaScript itself is not smart enough to tell the IoC container what's the type of this router, like what exactly needs to be injected into this class. And that's where you have to use decorators. And decorators basically let you inspect the types of the variables and do all like automatic resolution behind the scenes. So we are going to use this inject decorator from the same package that AdonisJS fold. Now this decorator, using the TypeScript reflection API, will be able to figure out that this first argument is looking for the class router. That's possible because of the TypeScript reflection API that they provide. Now we have to do this with router as well, because it also relies on a dependency. And if we want that automatic dependency injection to happen, so we have to use that decorator here as well. Let me copy the import, paste it here. And now if I run the code, it works fine. So basically, you don't have to worry about how dependencies are created. You don't have to, like build all these trees yourself. You can just call container.make, and then container will be smart enough to figure it out for you as long as you are using the inject decorator. Make sense?
Completely. And it's way simpler to use. Because here you show an example with three simple classes, but sometimes you accept to have like 3 or 4 or 5 classes inside yours, and those accept 2 or 3 classes too. So yeah, it's starting to have a big Christmas tree.
Yeah. So like when you start using dependency injection everywhere, like when you are like accepting dependencies as like constructor arguments, you will realize that you have like this really big tree, as you said, like the Christmas tree, and you have to like construct that entire tree somewhere before you can use the final class. And if you can, tell yourself, okay, I'm going to use container, and I will tell the container with the help of this decorator, then you can actually get rid of everything and just call like container.make. It will figure out everything for you, and it will build those classes behind the scenes for you. And one more thing, this inject decorator does not accept any arguments. You might see in some other implementations of the IoC container, other packages, they allow you to customize a lot of things. I personally decided not to do that. I want the API to be really simple. You just like drop this and everything works. There are like no hooks or knobs that you can control, because that might end up making things a lot complex. They may like give you bit more flexibility, or bit more power to do different things, but I think IoC container itself is not like a very well established thing within the JavaScript ecosystem, and on top of that, I don't want to make the entire thing really complex and really configurable. So that's the reason. It's like just one method, you call it, you cannot pass anything, and it just works. So yeah, that's a basic 101 introduction to how you accept dependencies and how container can make that for you. The main question is why you should be using it. Why should you even... Okay, we have a question from Kevin. I assume with circular dependency it explodes, or there's some magic that makes it work somehow. Right now, it will explode with circular dependencies, and there is no magic that can make it work. But if like a lot of people have scenarios where they run into circular dependencies, then it might be a good reason to see how we can fix it. But so far I haven't run into that issue, and I haven't even thought of fixing it. But yeah, it will explode. Cool. So yeah, that was like a very basic, simple example. Now we have some base ready. Maybe we can look at a bit more complex example on why you might be interested in using the IoC container. So let's go back and go to a new directory. Let's close this. Now, a common use case where you might be tempted to use dependency injection is when you want to mock or fake some dependencies when you're writing tests. So again, I have one more application over here. Let me first walk you through the code that I have within the source. So like in all of these examples, whenever you see the source directory, think all these classes or files are coming from some package. Right now, I haven't created packages, but you can think this is not your application code. It's coming from some package. So there is an HTTP server package, which gives you this very simple server class, and it has a start method, which creates the HTTP server, and it accepts a handler. And when it calls the handler, it gives it the HTTP context. So, kind of mimicking what AdonisJS does. HTTP context is really simple. It gives you access to the Node.js, REQ, and RES objects. And finally, we have this app folder in which we have a very simple controller. That controller uses a user service. So here we are saying new user service, find the user with ID 1. And then that user service internally using a subscription service. So here we are saying we are returning the user, and then we are also returning their subscriptions. So we are saying new subscription service, get subscriptions for this particular user of user with this ID. And then we have a subscription service, which is using a payment gateway, which is Stripe right now. And it's saying, hey, get me all the subscriptions for this user. So a very typical workflow that you might have, that you want to get the user, you want to pull their subscriptions, and then might be you're relying on some third-party payment gateway to pull those subscriptions because they are stored over there. And right now I have written this code like a lot of us might write if we don't want to use dependency injection. We just import the classes, we create their instances, and we call methods on them. But now let's say when we are writing test, we want to not call the Stripe gateway because it may, like very first, like we don't have customers, or maybe we don't want to use real customers within our test, or like simply we don't want to hit a third-party service when we are writing tests. And if I go to the place where we are, like creating the HTTP server and calling this controller, we have no way to control which payment gateway this user controller should use. We are creating a new instance of it, and we are calling the index method, and payment gateway is getting used deep under, like some third or fourth dependency, and we have like no simple way to mock or fake that out. And what a lot of applications do is they use the same architecture like we have right now, and they use jest mocks. So if I go to jest website, jest mocks, is this the one? No.
Yeah, they're all kind of like huge.
Yeah. So again, they have like a very same setup. They have a sound player, then they have a sound player consumer. They are like importing it out here on the top, and here they are not accepting an instance of it. They're just creating it within the class. And then they tell you, like, if you want to mock it, you can call this method just.mock and give the path to the module, and they will like mock it for you. And then they have also more, like advanced ways of doing it. Like if you want to also define how the mock implementation looks like. So you can say just.mock sound player and then create a file in some specific directory. And here you can, like export the mock with the implementation that you want. Now, there is a big issue with this. I think there are like a couple of issues with this. First, they like hack into the module system. So far, they was doing it for CommonJS. Now with ESM, it no longer works because ESM does not allow you to basically hack into the module system. They don't expose it anywhere, whereas CommonJS used to do that. And so if you want to do like write mocks, you cannot do it with ESM. It doesn't work. Second, I don't think it's type safe. So if I go to this file and return something from here, I don't think TypeScript is going to have any idea what the type of this return value should be. Like TypeScript does not know what the original module looks like. So there is like no type safety in that. So these are like two big issues that I see with this style of mocking. And if you go to dependency injection and you use a container, you can very easily solve it. And other languages are like already doing it. So it's not like something new, but I think like it's like way better than hacking into the module system and hitting limitations over there. So does everything make sense so far?
Yep. Perfect. And people will be amazed. I know what you're going to show.
Yeah. So very first, what I'm going to do is I'm like going to run this example. Now this TS-ESM is alias that I'm using to run node with a loader TS node/ESM. So that's like an easy way to run TypeScript files. And I think I'm running on port 3000. If I go here, this is like the response from the user's controller, which is hitting the user service, which is hitting the subscription service. Now, do is we'll go to this user's controller. Instead of creating an instance of user service over here, we will accept it as a dependency. So here we say constructor and private user service. And here we will say this dot user service find. Next, we will go to the user service and we'll do the same thing. Again, we are not going to create like local instances of anything. We will just accept it here. So private subscription service should be like this. And here we will say this. And finally, we'll go to subscription service and we will do the same thing. Private gateway. And here we say this dot gateway. And finally, if we come back to our index file, here we will, have to define, pass the user service. So here we say constant, or maybe new user service, and give that to user service. But now user service needs the subscription service, so we have to create that as well. So here we say subscription service. And finally, we have to pull in a gateway as well. So constant gateway. And here we say subscription service. And finally, we can pass it to user service out here. And I hope everything should work fine. So if I refresh, yep, everything works fine. But again, we have this problem that we have to build this entire tree by ourselves. And maybe this is one of the reasons a lot of people try to opt into the easier way, that is just mocks versus building, a flow which is a bit loose and, it's not hacking into the module system. But with the container, we can actually get rid of all this. We just need the controller. And here we can say constant users controller. And we'll say container.make. And then we'll say this should be a wait. And finally, we just have to decorate them with this decorator. Also here. And finally with subscription service as well. So let's restart. I hope it should work. Yep, everything works. So now finally we ended up with this system where instead of creating an instance of users controller by hand, we are using the container, and every other class asks for the dependencies using dependency injection versus creating local instances of that class within that file. And once we have done this, we are basically giving the control of creating all the classes to the container, and therefore we will be able to tell the container to basically fake mock dependencies for us. Now, if I go to this test file, it does the same thing, basically importing supertest to make HTTP calls. Then I'm importing the index file, which will basically start the HTTP server so that we can hit our HTTP server endpoint. And when I'm writing this test, I want a way to not call the Stripe gateway and instead provide something fake for the test to work. And what I can do for that is I can say container.swap. And which class do I want to swap? Here I'll say Stripe gateway. And here I can return a new implementation. So if I return an empty object, it will fail because TypeScript is telling me that the value that you are returning is not compatible with this class. So you have type safety right away. So what I can do is I can say class fake gateway extends Stripe gateway, and I can override any methods that I want. So let's copy this. In fact, let's copy the entire method, paste it here, and let's say add one property is fake true. And from here, we'll say new fake gateway. So we are like creating our fake gateway. You can create it any way you want. Maybe you can use like some third-party module which can, like mock methods on an existing class. I'm just choosing something really simple and return that new implementation from this callback. And now if I hit this endpoint, I will get a subscription return from this gateway. So let's do that. Here you can see we have isFake property. That means when the request went to the server, a dependency got faked. We don't have to change anything within our code. It's like working as it was, just hitting that endpoint. Like before hitting that endpoint, we swapped the dependency. And once you're done with your test, you can basically restore it. So if I copy this, here I say container dot restore Stripe gateway. Let's make another call. So the first one has isFake, the other one does not because we have restored the fake, or you can, like the swap implementation we provided. So does that make sense so far?
Yeah, it's really easy to use. The type safety is awesome on swap because currently you can actually do that in Adonis 5, but you don't have any type safety, I believe.
Yeah, like there was some rough edges in, like there are some rough edges in Adonis 5. And that's the reason like it never got documented, because I knew I will be changing the API because the flow was not desired. And this looks like really great. You just have to, like decide, okay, I'm going to opt into dependency injection for places where I know I will be, mocking or faking dependencies when I'm writing tests. Now, again, like this is very important thing. Like I don't see, or I don't advise people to change their entire application and inject every single dependency as, a constructor dependency or a method dependency. It's fine to have like top level imports and just use the things that you were using, like the way you were using earlier. But for places where you will be, swapping implementations, there it makes sense that you accept those implementations as dependencies versus hard coding them. And maybe if you are like developing packages, then it can be nice to accept dependencies, like from outside in versus having sure. hard requirements on something. Now Kevin has a question. How DI looks compiled? It just adds import and then makes new class to constructor. So if you compile it, your code will remain pretty much the same because we are not like transforming your code in any way that emits a different JavaScript. So yes, it will also work with like JavaScript decorators. They haven't like, I think they are in stage 3 right now, but once they land into mainstream, like this thing will even work with JavaScript decorators. But in JavaScript, you do not have types. So when you put the decorator out here on the top, decorator doesn't know what's the type of this variable or like this property. So we won't be able to use reflection. Whereas if you use the same decorator in TypeScript, we will be able to use reflection and figure out like what's the type of this particular property out here, if that makes sense.
Yeah.
So yeah, in a nutshell, like TypeScript will be required if you want like this really simple sweet API. Cool. Another thing I think we can cover is we can even accept this dependency within our methods. So it doesn't have to be a constructor dependency. And I think it makes a lot of sense within your controllers because your controllers have like multiple methods, and all of those methods may have like different requirements or may need different dependencies. So instead of pulling, like everything within the constructor, you can ask for dependencies within the method specific to that particular method. So again, if we run this code, it should work fine. Nope, it does not. Why is that? We got inject, we got this.
Is it because it should come first? Yeah.
No, it's because we are calling our method manually. Again, we have to tell the container to call this method and inject its dependencies. So we can say container dot.
And for all people watching, this will be like built in Adonis 6. You don't have to write this code here. It's just for the example.
Yeah. So basically, like all the code that I'm writing out here is anyways you never write within your AdonisJS application. So like this code is written inside a package, which looks at the current request, figure out which controller that request should be handled by, and we are like calling all this code behind the scenes. So if you do this, now give it a run. Yep, that works. So we're basically using method injection now instead of constructor injection. And this is how it works. You like tell on which class instance you want to call the method, then the name of the method. Again, you have like type safety here, so it tells you all the available methods on that class. And then any dependencies that should be fixed. So what you're telling is, no matter what that method is asking for, always give them the HTTP context as the first argument. So if we go to our controller, the first thing will always be the context. And after the first, argument, you can tell the container to look up classes for you. All right, so again, a container is like really simple. There is like no magic behind it. It's a thing that you see when your code is reaching to a point where it's not testable because you have some things that you want to swap. And the answer to that is really simple, that you start accepting dependencies and then use container to build those dependencies and also swap the ones during testing. So this is like the one major use case of using the container. The other one is bindings. So, yep, thank you. So, so the other one is bindings. I'm not sure how many of you have seen code within the AdonisJS docs or code base, which is something like this: container dot bind or container dot singleton, or maybe container dot use. And container dot make.
This is many. This is used for package builders. You should see that on providers if you're building packages.
Yeah. Yep. So let's talk about it. I created an example for that as well. So let's go to bindings, open the code, and here you go. So let's say now, bindings are essentially when you are either building packages or either you want to construct a class and its construction logic needs more than just saying new and then the class name. So let's first focus on packages for now. So out here we have a database class, and what we want is, one second, maybe we should start from looking at the code first. So again, everything like within the app directory is the code within your application. So here we have a user service, and this user service is like using dependency injection to say, give me an instance of the database, and then it calls this method on the database class. Similarly, we have a post service. It also using dependency injection to pull in an instance of database. Now, if I go to our main index file, again, I'm not using container right now. So I create an instance of this database class. And again, it's inside the source folder, so you can assume it's coming from some package. And that package uses Next under the hood to make database queries. And we have like this really simple database class, which takes the config and then gives you a method to create a Next query builder. So this is like coming from a package. So out here in the entry point of my application, I'm creating a new instance of the database. I'm giving the config. Then I create these two services and I call the fetch method on them. So this is like really simple flow, no container is used. We are just using dependency injection and we are asking for the database instance in our services. So again, if we run it, we are making the actual database queries and we are fetching to users and to posts. So let's see what happens when we start to use the container. So what I'm going to do, I'll say container, and here I'll say await container.make user service. So let's copy this. And let's do it for post service as well. So, all right. And now we don't need this here. And we basically call the fetch method on both the services. And we do this as well. So if I try to run the code, it fails because it says this.database.query is not a method. That means we need to use our inject decorator. So this is like basically what we have been doing so far. And here we go. If I run again, it again fails because now what happens is when we go to a database class, it needs the config to basically create the database connection. And container has like no idea how to pull this config. And even if you like use the inject decorator, it will not work because like config is not some class. It's like a runtime object that you define when you want to use the class. And this is where bindings can really help you. So because the container is not able to figure out how to basically grab this config, you can tell the container how to do that. So what we're going to do is we're going to say container.bind, then the name of the class that we want to bind to the container. And then we have a callback. It should return back an instance of this class. So it's going to be basically the same thing. Return it. And let's uncomment it. So again, we are doing the same thing, but this time we are telling the container that anytime anyone asks for this database class, give them whatever like is the return value of this function. So basically, container doesn't have to do any work to figure out how to like build a database class. We are doing it ourselves. Now, if I run this code, it works fine. But there is a problem right now. Out here, if you see, I have like two log statements, which is creating next instance and creating next instance. And this log statement comes from this constructor method. So what we are basically doing is every time anyone asks for the database class, we are creating a fresh instance of next. And behind the scene, next is going to basically create a fresh instance of the database dialect, which is not a good thing. Ideally, we should be reusing the same connection across our entire code base. We should not be like creating too many connections. So to overcome that problem, instead of saying container.bind, we can say container.singleton. Here we are telling the container that only create an instance of this class once, and then just cache it. And whenever someone asks for it, give them the same instance again and again. So if I run that code, you see like we get that log statement only once and not multiple times. All right. So does it make sense so far? The same question.
Yeah, it makes sense. That's already what people should do in Adonis Fun when they create packages. If your classes can be cached, do it.
Yeah. So like this is how you can basically tell the container to build some complex classes that it cannot figure out by itself. But there is like there is more we can do. Very first, this code that we are writing it within our application, because let's assume this database is a package. It has no idea which configuration you want to use in order to basically even write this code. This is like something only the person building the app can tell. So what we can do is, what if like we make a promise, or let's say the package says, hey, you don't even have to like write this code if you can do a really simple thing for me. And that is, if you can bind let's say something called dpconfig to the container like this, then you won't even have to like create an instance of this class. I will be able to do it. So what we can do is, now we can go to our source folder, which is like basically the place for the package, and we can create a provider. Let's say export function provider, and here let's grab a database class, and we will accept the container as a dependency. So and here we can say container dot make dbconfig, and this should be awaited. This can be async. So, and now we can come to our this file. We can get rid of that import and do. So let's try to run the code first, and then I'll talk about it. Yep, it works. So let's see what really is happening right now. So very first, the code that's required to like build classes or objects that your application needs, we are moving all that code, all that boilerplate away from your application, and we are moving it within the package. So you don't have to like worry about how to create these classes. The person who has built the package can basically write these providers, and so like provider is like basically a function that takes the container and it puts something into the container then. And using a provider, we can basically create these complex classes and put them, within the container. And in your application, you only have to worry with just the config. Now, in a real AdonisJS application, this config does not even, live in random files. We have a dedicated config directory. So this config makes its way to the config directory, and then when we boot the application, we bind all these configs within the container, just the same way we are doing it over here by hand. And the packages can like basically ask for the config, if all this like really makes sense.
Yeah, and we should be careful to use the binding name, which is unique.
Yeah.
To avoid erasing things from the user land.
Yeah. So just to give you, like a bit of perspective. So anywhere out here, like when you're using, like the database object, you are not creating an instance of it. You're not passing it the config. You just import it, you use it, and it's ready to go. And that's happening because we are, like putting these configured objects within the container, if all that makes sense.
Yeah.
Cool. Now, one more thing we can talk about related to bindings. That is, so let's say we don't want to use dependency injection. We want to import the database out here on the top and just use it. Because very first, I'm not going to swap the database anywhere in my application, neither in my test. I want my test to just go ahead, hit the database. So I don't want to, just keep on accepting dependencies within the constructor, even if they don't serve any purpose. I just want to have top level imports and get everything working. So, exactly like the way we are doing over here. So we are not using dependency injection. We import and then we use the database.
Yep.
So what we can do is we can put another binding. This time, let's say, give it a name of string database, or maybe we can say AdonisJS /database. And out here, we get a resolver. We say await resolver.make database. So we are basically adding one more binding to the container as a string, and then we are using the container resolver to call the make method, which basically gives you the output of this callback. I hope I'm not making it complex.
No, it's fine. At least for me. I don't know if people on the chat are following, but they can rewatch the video in case.
Yeah. So let's say now we don't want to use dependency injection and we just want to pull things from the container and then just use them. So what we can do is we can say container, and out here we can say db await container.make AdonisJS /database. Was that it?
Yeah.
I think like this.
Yeah, with S. Yeah.
Yeah.
Perfect.
And then I can say db.query.select all. So again, one more try. Nope, that fails. It says db.query is not a function. Wow. So let's see why is that. So if you do console.log db, it gives me the string back, which is funny. Let me think. So we put a singleton here, and then we go to our user service. We tell it to make that binding, which looks fine to me. And over here, first this should be out here. Oh, I see why that happens. So for a second, I just have to do one thing. Let's move it out here to the bottom, and I'll explain why it's still failing. Maybe we have to make it a dynamic import. I'll explain if this is the reason why it's happening. So await import. All right. Yep, that works now. And the reason that was happening because we were importing our user service first, and we were calling this provider callback afterwards.
Right.
And therefore, this method was called even before provider has put anything into the container, if that makes sense.
Yeah, totally. Maybe it should throw an error if it cannot find inside the container something.
Yes, I think so. Like in case of strings, if you're saying give me something by the name of a string, then it should, yeah. But ideally, this will not happen because the place where we actually call all the providers, that code gets called even before any part of your application gets imported. So maybe you can think of us doing it out here itself. So like when
It's
we
during
create a new
the boot.
container, we, like
Mhm.
pull all the providers. So let's do that.
Yeah, basically it's during the boot of the application.
Yeah.
It's doing it only once when you start the app, and then the app is in memory. So
Yeah. So
you should never eat that.
So let's do that. Now it should work, I think. No such table users. Did I drop the tables? I don't know. But anyways, like at least the code is working.
Yeah.
Because now we are like doing all the bootstrap process within this file. We are registering our providers over here, and then we like import any application specific code out here. All right, I think this should go to the top as well because container needs this. I'm sorry.
Mm-hmm.
Like the flow is a bit messed up over here. Like we are writing all the code over here. But basically, you can also, like put bindings within the container, and then you can tell the container to resolve them using this method called container.make. However, this code doesn't look that great visually. Like out here in this file, we have some imports, and then when we need something from the container, we are like using this container.make method. And to overcome this, we have something like this that you have been writing in Adonis 5, or you have been writing right now. So behind the scene, every time we compile your TypeScript code base, we convert import database from like this thing to a container.make call. So when you write this, and when we compile your TypeScript code base, we convert it to this constant database equal to await container.make. So this is what like we do behind the scene to give like a nicer API to work with, which is like consistent. You're using imports everywhere. However, this thing also has a downside, and the downside is we have to rely on the TypeScript compiler in order for this to work. So if you have a vanilla JavaScript app, it will not work. If you use a TypeScript compiler, which does not support writing custom transforms, for example, SWC does not support it. At least like they don't used to support when I was investigating for Adonis 5. We cannot make all this work. So in Adonis 6, we won't be like doing any magic behind the scenes when compiling your code, and instead we can make it work really easily, and that will be, so if I go to source, and here I can create a file called db.ts, and from here I can say we need to pull in the container, and then we can say export default db, and out here we can say, now this might not make that much sense right now, but I'll explain it. So what we are essentially doing is, again, like we have all these relative paths here, but you can think this will be replaced with something like AdonisJS, Lucid, DB, because this is going to be the database package. So within the package code base, we will have these, like we are calling them services. So it will be like services/db.ts, which writes this container.make call behind the scenes for you so that you don't have to write it within your code base. And you can just, like import that module, which has like this 3-liner container.make, some container binding name, if all this makes sense.
Yeah, totally. And thanks to ESM imports, well, I mean, top level async await.
Yeah. Yep. That will be actually possible because of that. Otherwise, we won't be able to export anything if we cannot write await over here.
Yep.
Cool. So yeah, that's pretty much all like the IoC container is in a nutshell. We covered dependency injection, how we can, inject and build dependencies using the container API, how that makes testing really easier over using something like just mocks, which hack into the module system and kind of breaks with ESM. They may figure something out, but again, it's like a good indication that when you hack into the core of something which is not meant to be used that way, you can hit limitations.
Yeah.
And we also talked about bindings, why you might need them, and also how you can import the container bindings like out here on the top. And yeah, that's pretty much all. But happy to answer any questions anyone have. And I think this will help people understand container a bit. And of course, we're going to have documentation as well.
Yeah, that's something like hidden pretty much in all frameworks you use, or from JavaScript developer. I mean, this is fairly used in PHP, in JavaScript, in Java.NET, but not so much in JavaScript. So it's great to have like a good video like this one to show people how to use it, how it works behind the scene. Yeah. Maybe you can show, if you have time, of course, the middleware demonstration with tenants, where you can hook inside the resolver to check something, or you believe it will be too long?
I think we can get into it. So maybe first we can close this example. Let's go to the HTTP server. And I see what you actually mean.
Yeah.
So I think we have to change a few things for that. Let's see if we can do that. So we go to source, we create database. Yeah, that's a good question. Why did we have to use resolver.make instead of container.make inside singleton calls? So when we, for the very first time call container.call, very first time when we call container.make, internally container creates a resolver, which is, basically responsible for resolving all the dependencies. And then that single resolver instance is used to build that entire tree. So what you can do is, while that entire tree is getting built, you can bind new values to the resolver. So if I can show it somehow, let's say when you say container.make, we create a new resolver like this. All right. And then we use the APIs on this resolver to say resolver dot do something, to basically make a class. So let's say we have a method called make class, and here we pass the class to the to the resolver. And if this class has more dependencies, then all of them will be using this same resolver instance we created out here right after the container.make call. And while that entire tree is getting built, you can also put stuff into the resolver. So you can say that bind value, and it can be anything. And that value will be specific to that instance of resolver only. It won't get leaked to the entire container. And this can pretty much open up the API that Roman was talking about. So let's say, again, you have to visualize it if you can. So the HTTP request comes in. So again, the very first thing is we get an HTTP request, and then we, this is the AdonisJS HTTP server. It creates a resolver, and it uses that resolver to create a new instance of a middleware. Let's say it's a tenant middleware, right? And then it uses the same resolver to create the user's controller. And let's say then user's controller was relying on a user service. Again, it uses the same resolver for that user's service. And now this user service needs a database connection. But what you want to do is you have like a multi-tenant app. Within your tenant middleware, you say resolver dot bind, and you say, okay, whenever any class asks for the database class within this tree, or like within this local resolver instance, give them a new instance of database. And here you like pass in the tenant configuration based upon the request that you have received. So this user service will receive the value that you binded to the resolver. And again, if you get like multiple requests at the same time, each request will have a local resolver instance. So if you bind values, it stays to that resolver. It doesn't get leaked to the global container. But again, the thing will become really easy when we have everything in place, and maybe we can create an example to visually show it. But right now, the simple explanation can be it's like a single instance to build the entire tree.
Yeah, I believe you don't have to code anything. The example here you show is pretty much what I was talking about. So yeah.
Yeah. So now we have a question. Will it be hard to upgrade community packages to support AdonisJS v6? Nope, it won't be. So only code that you have to change, it's mainly going to be inside your providers, because the container APIs change a little bit. So right now, if you have a package, you might be using a method like container.use or container.resolve binding. They all will get replaced with container.make, like a single method. And then we have some methods like container dot it was like with bindings, something like that. Now this is like basically you say, hey, if AdonisJS core database exists, then like call this method. You have to replace that with the resolving hook. So it's like slight API changes within the provider, but you don't have to like change a single line of code within your implementation, unless your implementation classes was relying on the container internally, which ideally they should not.
Yeah, or if you were hooking inside core packages like the routing system, maybe you have to change a bit if the routing has breaking changes.
Yeah, but ideally,
it should be straightforward. Yeah.
But again, like as we said earlier, we are keeping the surface area of breaking changes within the actual APIs really low. It's all about moving to ESM and then changing the container a bit and removing things which Node can do right now versus us doing it. And a good example of that is the import aliases. So you don't have to use what we ship. You can use subpath imports that Node.js gives you right now. All right, then we have another question. Will it be possible to just briefly talk through the implementation details? I think it's about the package implementation details.
Yeah, I believe I understand it like that, at least.
Yeah, that's what I thought. Yeah. All right, let's see if we can. Where to start?
I will share the link inside the chat if people want to go ahead.
Cool. So I think the most... so one can be the resolver. The other one can be... Oh, there is provider, yeah. So the other one can be provider. One more thing I can show before we move forward is, let's go to basic example just to make things a bit more clear. So if I come over here and we do console.log to do local drive and we'll run this code. So do you see something on this class local drive? We have this static property called container injections. And then it says, okay, the constructor relies on something. And here it says function, but that's basically the way like the value gets logged in the console, but it's this router class. So what we are doing is using the inject decorator, we are putting, like some hints on the class itself that the container can use to find out what the class constructor wants, what, like the class method wants. So the role of the decorator is just to, inspect your classes and then to basically create, like this metadata object on the class itself. And if we go to our decorator, let's do that. So here is, like basically the inject decorator. Here we say if we don't have a property key, that means we are not injecting anything into, like, this decorator is not applied on a method, it's applied on constructor. Then we call this method. And here we are using reflect get metadata design param types. So this is the thing that I was talking about. This reflection API only works when you are using TypeScript and you have this config enable to do this emit decorator metadata. So if you remove this, then this method call will return null. Like the inject decorator won't be able to inspect anything. 1 second.
Yeah, and you have also to not use import type when you are typing your variable, because TypeScript will remove them from the compilation.
Yep. So just to give you an example, if you say type router, now this router property is not, like an actual class, but it's a type. So if I say router, new router, do you see like how TypeScript remove that type? If I add it back, it tells me, sorry, you cannot create an instance of this class because it's not a class anymore. It's just a type. And type gets removed when you compile your TypeScript code to JavaScript. So this code will like not even work. Therefore, when you're type hinting anything, it has to be like a concrete class, not a type or an interface, because they don't exist at runtime. Whereas if you're using languages like PHP, you can do that because interface is like part of PHP, not like some flavor of PHP. So again, like we are just defining some metadata on the class itself using this decorator, nothing fancy, like just 70 line of code. And a lot of them are even comments. So let's go to resolver and search for the make method. Yeah, this is where we do that. Like this is where we have the code how the make method works. So we check if we are working with a class or not. Is a class, we check for it. If binding is not a string, it's not a symbol, and it's not a class. So basically container can make three things for you. Either it can create an instance of a class for you, or it can resolve a binding that you have put into the container by saying container.bind or container.singleton. And a binding is always going to be either a string or it's going to be a symbol. Ideally, we recommend strings, but some people can, like think of situations where string cannot be unique enough and they want to deal with symbols. So they can also like bind values and give the name of the binding as a symbol.
Yep.
So if it's not any of these, then we cannot resolve it. We return the value back as it is. Then we check if we have any swaps in place. Then we resolve the swaps over the actual value because swap has like the top level precedence over anything else. Then we check if the thing that you're resolving is a binding. That means you have registered it by calling .bind or singleton methods. We resolve them first, and then we like emit some events so that you can observe how container is working. Then with bindings, we also have binding values. Documentation talks about them, so I will skip it for now. Binding values, container binding values. Yeah, so we basically have like two layers. So we have like binding values at resolver level, like the thing that I was talking about. That resolver can have like local bindings within the container, and then there are like global container bindings as well. So basically like some checks what should be resolved first over the other. And finally, if you're dealing with a class, we go ahead and use a provider and tell it, okay, take this class and look for underscore constructor properties, and then like giving some stuff to the provider to actually function, and also giving the runtime values. And yeah, that's pretty much all. And if we go to our provider like does the actual heavy lifting. So the provider check if your class has a static property called container injections, something that you can see over here. And if it has if it does not have container injections, or if it does not have like container injections for that specific property, which is like constructor in this case, then it won't do anything. Otherwise it will loop over them and try to resolve them using the container recursively. So that's pretty much how it all works.
Yeah, at the end it's JavaScript. But
yeah,
I believe you did a pretty good job documenting that on the README. I mean, how to use it and how it works, like in the user land stuff, not behind the scene. And people should know that this is framework agnostic, so you can use it in your scripts if you want, or in any other application which is not Adonis, even if we don't recommend that.
Yeah, you can do that. Like we only have like one dependency, which is like some utilities. We don't have any like Adonis specific dependencies over here, and you can pretty much use it anywhere inside JavaScript and TypeScript projects. So, and again, like even the implementation is really simple. Like if you look at it, of course, there are going to be some inner workings to make sure things, cover some edge cases. But at a top level, it's like you put a decorator. The decorator uses the reflection API to find out what your class needs. It drops all that information on the class itself, so that when you give this class to the container knows how to, like what your class actually needs, and then it create those dependencies and return you the final value back. So that's pretty much all like is happening in nutshell.
Yep.
So yeah. Okay, we have another question. This is useful to mock classes during test. Can it be used to mock functions too? No. So container does not resolve functions. It only build classes. So if container does not build functions, so it cannot mock functions. But if it's a method on a class, then you can do it. But if it's like top level functions, then container does not even entertain them, so it cannot even mock them.
And when you say you can do it, you need to create a new class extending the other one, and you just replace the method you want to replace on your classes, and then you swap it. I believe you did it in not this example, but the HTTP server one.
So if I go to test,
here we're swapping.
Yeah. So it depends how people like to mock things. So the basic idea is you're telling container very first, anytime someone asks for this class, give them this class. Now, how you set up this class is totally up to you. Maybe you can create a new class, which extends the actual implementation, and you override specific methods. Maybe you don't want to do that at all, and you use something like Senin to say I'm just making up the syntax right now. Synon.mock Stripe gateway, and this method called like get subscriptions, and then like Synon returns a new object, and then you return that from here. So that actual mocking, if you want, you can use Synon or any other package. I personally prefer to do it this way, where like I basically set up a fake implementation altogether, and there are like so many articles where fakes can be better than mocks actually.
Yep.
And then I just like override the ones that I want to override, and this is like really simple. Don't have to pull in any additional dependencies. But yes, if you have like a function like something like this, and you want container to swap this, no, it cannot do that.
Cool.
Cool. Yeah, I think we covered some ground. Pretty much like this is like what the container is in a nutshell. There is like nothing else. Yeah, but that won't work. Like it's like so there are like a lot of things like how, so when you say, hey, fake this to do, so you're saying container.singleton, you're basically like giving a string. You can do that, but like have to see how practically it makes sense, like how you are using that string based binding. But the code that you shared, that should work, because here you are like putting that actual function behind a string based binding, so that should work. But again, like practically it depends like how you're using that function, how you're resolving it from the container where you fake it.
Yeah, and maybe it will be easier to just create a class with a static method on it and swap it.
Yeah,
it will be much better TypeScript wise. I mean, because you will have all the typing.
Yeah.
During the swapping phase, I mean, because maybe you were not here at the beginning, but you can swap string-based things. But if you do that, you lose all the typing. Here, if Aman changed the remove the get subscription, it doesn't extend the well. If you return from the swap something else, TypeScript will scream at you because it's not following the implementation of the Stripe gateway.
Like if I return an object, it's pretty much like, like this object is not assignable to what the actual implementation is returning. But if I return an empty array, it works fine because now the shape of the return value is same. So you pretty much like get a lot of type safety because of this.
Yeah.
Cool. So
I believe we're good. No more question.
Yep.
Yeah, I hope everyone is hyped for V6.
Yeah, at least I know Kevin is.
Yeah. Perfect.
Yeah. Do you have any questions?
I don't. So it's the third time I see like this this IoC container, and I'm always hyped. So that's good.
Cool.
That's so cool. Yeah. And maybe, well, we didn't discuss that, but doing all of this, all right, but for an Adonis application currently, when you like control click on the imports, it goes straight to the typings, because we have typings and then we have implementation. If you already saw an Adonis package, you have this Adonis typings directory at the root, and then if we use this container, it will be removed, right?
Yep. So this is how it is right now. We were like doing a bit of dance earlier. So
because we need to declare ambient modules with TypeScript, because TypeScript doesn't know how to resolve this at IoC things, right? So that was a big issue for package maintainer, because they need to be sure that the types is like synced with the implementation. And for people who want to just see the code, they will just jump to the typings. So now you don't have this anymore with the implementation. If you don't use string-based, just let's be cleared.
Yeah.
If you use string-based, you will have this.
Yeah. So basically, like you actually like write your implementation somewhere. So this is like an example of a package. So here is like the actual implementation. But within our applications, we have like these at the rate ISC Adonis code encryption style of imports, which TypeScript does not know about. This is like a thing which just exists and gets replaced with container.make after code gets compiled. But before the code gets compiled, TypeScript needs to know like, hey, what is this? Like, what are the things available inside this namespace? So we have to like define these declare module, which is called ambient modules in TypeScript, to basically like create type only modules. So again, you don't have to do all this. If you're maintaining a package, you can just write the implementation and it will work. You don't have to also have interfaces and then classes. But if you keep them, that's also fine. But if you want to remove them, you can just like pretty much control delete the entire file.
Yep. Great.
Yep. That was pretty much like, it's like you're creating the same package twice.
Yeah, you need to keep them in sync twice also.
Yeah, ideally, like you don't have to, because you have an interface, so you can make your class implement it. So TypeScript will do that for you. But it's still like if you change something, TypeScript will yell at you. Then you have to go ahead and make that change within the class as well. But yeah, this will be like easier. For the application, it doesn't change much, but for the packages, it does.
Cool. Yeah.
Cool.
Everyone is hyped. Cool.
So yeah, if that's pretty much all we have to talk about, then maybe we can wrap up.
Yeah, sure. Go ahead. Yeah, I'm good.
Cool. Then
so see you soon.
See ya. Ciao.
Ciao.